Okay, I think we're ready to start, inshallah. Okay. So again, in the future, if you miss a quiz or something like that, just let me know. So because the whole class is expecting their stuff back, but I have to keep holding on to it. And just let me know, inshallah. Did I already give you the formula for slope?
Yeah.
This is just a review for anybody who was absent that day. Move this way. So the slope formula, you're going to need this again today, so I'm going to put this down because it's a Monday. It always looks like this whenever you're in parametrics mode. And then they can ask you a ton of questions based upon that. And I did, I think, a couple of examples with you. I think we did this example where we found the slope of a tangent line. Did this example over here where we found where you would have a vertical tangent. Yes, no? Did I do that example?
Yeah.
I did this?
So we finished? No, we didn't finish it. Figure out a ratio to do on dx and find therefore dx over dt equals 0. Then we solve t equals 0. Then we graph.
So I did this. Alright. Okay, let's go ahead and start all fresh. So go back to your old examples, and I have for you guys a new function, parametric function, which is called x equals cos t and y equals sin t. And your job is to find the slope of the tangent line to this, and specifically at the value of pi over 3. So go ahead and start without a calculator.
Did you turn it off completely?
You guys, here's how you find the slope of the tangent line. You begin by taking a derivative of the x's and the y's. Please be careful. I make this mistake all the time. It's the derivative of the y's over the derivative of the x's. Just usually what happens is we take this in the order of x, y, but it doesn't fit into the formula in that way. And then as a Calc BC student, please don't mix up derivatives with integrations. I've seen that a lot. Besides that, the trigonometry you guys have always been really good at, so not too concerned about it. And this is the slope of the tangent line. Any questions? Yes. Good. Any other questions? Okay. Now I have a question for you then. Now can you go back to the equation that we established? And your job is to find the vertical tangents and the horizontal tangents. So I want you to set it up the way that we have learned in lecture about how you discuss vertical tangents, how you discuss horizontal tangents, and then you begin to solve for where they might actually be. All right?
Do they have an interval? And Sam, also. What was it?
It was 0 to 2 pi.
It's not written here, but I think
Including?
it was 0 to 2 pi in the previous one. Yeah, 0 to 2.
Including?
Yeah, I mean 2 pi is 0, so just pick
Same
one.
thing.
Generally we start from 0 and leave out pi. Please take a look at the answers. While you're processing this, I just want to remind you again that we've already graphed this in a different lecture. Do you remember what the shape of this graph was when we graphed x and y to be the way that they are?
Yes.
Very popular shape. Thank you. Is a unit circle. And essentially what you just did using calculus is you found the location of the two vertical tangents. Obviously, if this is a circle, here is the location of the first vertical tangent. It's at 0. And as Mason said, you call it 0, you call it 2 pi, we get that it's the same thing. Then over here, there's another vertical tangent. So you'll have to do something like this in the homework. So you need to know what do I set equal to 0 in order to achieve this. Then take a look at these bottom ones. These are your horizontal tangents. So the one at the top is a horizontal tangent, and the one at the bottom is a horizontal tangent. So that's what that right there told you, the two locations of the horizontal tangents. In the previous example, there were no horizontal tangents, so I wanted you to see that firsthand. Do you have a question?
Yeah, I don't know, maybe I'm overthinking, but when it's negative sine t, does it have an impact on like 0 pi or
Not
or
really. The negative just divides
Divide
out,
out.
multiplies out. It's just as good as not being there. It's a good question. Any other questions? Okay, so I think now we move forward to one of the most confusing parts of this lesson. I have taught this so many times, and it's the same thing students forget over and over again. So last year, I did an experiment, made a slide that explicitly mentioned where students go wrong, and I tried to see, does it make any impact? It's hard to say. I don't think anything changed. I think people still make the same mistake over and over again. So I guess I'm mentioning this to you again. So there's something in this formula that people almost always mess up, okay? Because it's not intuitive. So let me ask you this. If I had an equation like t to the power of 4, right guys? What is its second derivative? What is its second derivative?
4t.
That would be its,
12 squared.
that would be its first derivative, right, me?
Oh, yeah.
So its second derivative is?
12 t squared.
Agreed? So what did you simply do?
Took a derivative
Took a
twice.
derivative and then?
Took another derivative.
Took another. In parametrics, that's not how it works. Okay? You have to make that a big deal. Otherwise, you're going to make the same mistake every group of students make every single year. Okay? So, yeah, what a lot of students have done in the past, let me tell you their mistake. Maybe this will help. What they do is they take this and they simply take its derivative and they say, there you go, that's the second derivative. And that is not the second derivative. So here is the second derivative formula. This is going to help you tell the concavity of a parametric curve. And it works like this. It says if you want that second derivative, look, one of the things that's deceiving about it is initially it looks like the same way that it does in function mode, right? D squared y dx squared. However, the way you go about it is very different, all right? So the top says d dt of dy dx, and that's basically doing what you guys are thinking in your mind anyway. Take a derivative of the thing that you already have. That's all that stands for. But what more does the formula ask you to do though? Yes, this is the big deal. So maybe in a different color, I don't know. I just want people to stop forgetting this fact and losing an interesting, an easy point. So in some way, jot it down so you don't make the same mistake all my students make every single year. So this needs to be done as well, okay? I made a really big arrow to help you to accept that. Hopefully it works, inshallah. I want to show you just briefly why they essentially say this. I don't know if I'll be successful in it, but here goes. If you go back to the derivative of the equation, notice how it's defined in terms of t. So if you took its derivative, it would still be defined in terms of t. So that's why that right there is over there. It says dt. So they know that this is gonna be in terms of t's, so that's why it says ddt. On the bottom, do we already have this on the board?
Yeah.
And what is it? Okay, so you have to additionally divide by negative sine t. That's the part that everybody messes up, okay? So once you do that, then you've basically found the concavity of a parametric curve. So let's give it a shot. Let's go all the way back to the same question. I keep bouncing around basically two functions. This polynomial looking function and then the sine cosine function. So let me teach it to you guys. We already on a different day found the first derivative. So just to repeat myself, because I know that on some days somebody was absent, on some other days somebody else was absent, so I don't want to hold you to that. So we begin by taking dy dx. The way you find dy dx, once again, you could do some of this in your head. The derivative of y with respect to t is 1/2. The derivative of x with respect to t is 2t. And that gives you 1/4t. Are you guys okay with that, yes or no?
Yeah.
Okay, now you don't stop there. The question says, can you find the concavity of it? So that's going to require the second derivative. So let's run through this together as a class. You begin by writing down d squared y dx squared. Okay, now help me with this derivative. This is not something easy that you can do in your head. A lot of people mess this up when they try to do it in their head. What would you first need to do with this in order to take its derivative?
Bring it to the top.
Beautiful job. So I'm going to bring that t to the top and make it t to the power negative 1, and then take its derivative. So what do you guys get for the derivative of 1/4t?
1/4.
Anyone?
1/4. Negative
Negative 4 over
1/4
t squared.
Negative 1/4t squared. Questions about that? You guys, what you just achieved there is the top. What are we still missing to talk about? Okay, so do that now. Go to the bottom of it, the part that people tend to forget. Go find your dx dt. That was simply what? What was dx dt?
2t.
Thank you. So put 2t additionally in there. And then simplify that again. Very nice. You end up with negative 1 over 8t cubed. I thought to myself before lecture that if there's a class that won't forget this year, it's going to be your class. So, inshallah. Alright? Do they want us to evaluate it somewhere?
Yeah, t equals 2.
Okay, so go ahead, plug a 2 into it, and then we'll interpret what it means to have, once again, a concavity, which is, looks like it's going to be a negative concavity. What do we end up with?
Negative 1 over 64.
Alright, here goes. D squared y, dx squared. You write down like this, t equals 2, and then you plug in the 2, and you end up with 2 cubed is 8, and then 8 eighths are 64, so thank you very much. So negative 1 over 64. So this parametric curve, recall it looks something like this over here. What is that simply telling you about the parametric curve? It's what? Concave down. So please, thank you. So kindly write down, it's concave down at t equals 2. It's not a hard lesson for this reason. It's not like you're learning brand new calculus. It's the same stuff as before. You're just learning it in a new light, and that light is called parametrics. Okay? Alright, so what I did here, instead of going back to this function, I brought in some other examples now. So go ahead, your job is to find the second derivative. What is it that gives it away? How do I even know this is parametric? How is this not like a regular question? What do you guys see? I see t's, right? I see x defined in terms of t and y defined in terms of t. So go ahead, give it a shot. How did you guys do? You got it? Nobody made the same mistake that everybody makes? Question. If somebody had simply taken this thing's derivative and thought that that was the end of it, is there an answer choice there that says that?
Yeah.
So you're pretty convinced that you're right, but you're missing an important component of it. Questions? Alright. To be fair, it's not immediately after I teach it that people forget. It's like 2 days later. So, alright. Go ahead, try again. Heads up, I might be getting observed soon, so maybe my observer will walk in at some point today, tomorrow, I don't know. It's a surprise.
Do they observe all your classes or just
Choose one.
They just pick one randomly. If I do a good job, then things are good. If I do a bad job, then they can fire me for it. Do you know who my observer is?
this is Spark? This is a student.
Mr. Clark and Mrs. Susanna used to show up, and one year Mr. Shelby showed up. They're like, I don't know what this guy's doing. So they said, you know what? Just give it to Sister Reen, make her do it. So she's the last person standing who walks into my classes and understands what I'm talking about. Everyone else is like, I don't know what he's saying. What is he talking about? So. So yeah, it might be today, it might be tomorrow. I don't know. I get this. You guys will see that they consistently keep giving you the wrong answer choice, so be careful. All right, it requires one. You forgot?
No, I just think.
Oh, okay, just in a row.
Say, oh, good.
I was waiting for somebody to admit that they forgot already. So, all right, questions? So, one more time. No, Alice, you wouldn't use kosher because you can actually.
He hears everything.
What's that? Oh, I thought he was asking me. I don't respond to it because I'm trying to eavesdrop. I respond to it because I thought it was directed towards me.
I took the wrong derivative.
I can hear what Nadia whispers. I think you are in a safe spot over there. I know you don't say
There's
anything.
nobody even in his vicinity, yeah. They
Yeah.
talk to the walls.
I think more than you guys talking was, I was having to hear what you were saying when you were talking. That was bothering me. I don't want to be an eavesdropper. So. Did I ever tell you that story about the UWM
Yeah, you told me.
time?
No.
No, about how it goes.
No, one girl.
Yeah. Girls back there.
Wait, what?
They thought I was cute, and they were saying.
Oh, yeah.
Well, I don't remember this
Told me
story.
that?
You never?
Yeah, you told us.
You didn't tell us.
When did I tell it to you?
You did tell us it was like the freshman year.
Sophomore year.
No, sophomore. Sophomore.
I don't remember that far back.
No, I remember.
Wait, you told your wife though, right?
Huh?
You told your wife?
Crazy? No. I don't tell my wife.
He said, are you crazy?
I don't want to die. I have a little bit to live. That's alright. She didn't do anything about it. They're all lies anyway. Alright. Yeah. Acute hearing. That's the problem.
Calm down.
I would do this. Are you sure? Yeah, I do.
This one's not that straightforward. So maybe you get stuck in this. I don't know.
Can we simplify midway through?
Yes. If you recall the rule that Sister Reen taught. No, she's not here yet. But anyway, the bases are the same. So what can you do with the exponents? Subtract. So 3t minus 2t gives you single t.
Well, we did not do that. Sorry.
Right? Were you using the quotient rule? Were you going to use the quotient rule? Like Hadis was going to use the quotient rule?
Yeah.
That's why I inspired. I inspired so
Inspired all the wrong thoughts. Alright, that's alright, Hadis. I appreciate you, man. So, then,
Bro, I didn't think
yes, you can simplify
Yeah,
this
you're
because
right.
it's basically the same, so algebraically it works. Then the derivative of that is really not that bad. It's 1 over 2. It's
Same
basically
thing.
itself.
Yeah.
Good. Now go back and find dx dt. So now you have 1 over 2 and 6. What does 1 over 2 and 6 simplify to? 1 over 12. Can you apply that same rule that we earlier applied? Yes or no?
Yes.
Same base, you can subtract, so it becomes t minus 2t. So technically it's E negative t, but usually they don't give that answer. They usually will simplify it a
1
little bit
over
further.
12.
So letter A would be the correct answer on this one. So this one had a slight more difficulty in it, so I showed it to you afterwards.